All right, so in this next section, you're going to see a lot that involves area between curves. And so in particular, what I want you to think about is, what does an integral mean? When you do the area underneath a function, what it does is it finds all the area underneath that line, right? So if I am trying to limit it, in other words, I want to bind it from the bottom here so that it's limited to what it can do, or even on the left and the right, we have to be able to accommodate that. Again, typically when we do the area, we limit even from the left and the right, just simply by saying we want the area under that curve, but it would have calculated all the way underneath the whole thing. So what basically has to happen is, if we see that we want it between some curves, what we're going to do is we're going to take this bottom curve, and it also will find the area underneath itself. But instead of including it, what we want to do is figure out what that area is and subtract it from that whole thing. And so here's the bottom line. It is the integral, the integral usually means the top minus the bottom. Well, if we're doing between curves, what we basically are going to do is the integral of the top minus the integral of the bottom. Or we could subtract them first and then do the integral. It's a kind of a neat thing that you can actually do. So knowing that, let's do some examples of how that gets applied. And of course, that's our whole focus today, is to be able to do the area between two curves. Here, you might say, well, they're not curves, but they're lines, and we have a line and a parabola, and I want the area between them. And so what we're going to look at here is we have the area, right? And we want the top function. So it's always going to be the top minus the bottom here. So we're going to do of the first function, x plus 1. Now, what's the left side of this limit? You'll notice where they cross is at -1, and where they cross on the right is at 2. So if I want between, where these, right between these curves, I kind of have to use those left hand, right hands to determine that's part of it. And then what I'm going to do is, okay, the top covers everything underneath that line, everything. But what I want then is to find the area of this curve here and use that. And so what I would do then is subtract, and of course that's x squared minus 1, right? And so I'm going to use that as my second function, dx. Again, as I pointed out in the beginning, you could, instead of finding them individually, because we could do them individually and then kind of combine their answers, or I can simplify this whole thing here. In other words, I could say, oh, I've got x plus 1 minus x squared plus 1. So I've got a negative x squared plus x plus 2 dx, and do that integral. And that's really, in essence, what I'm going to do. And so if I do that, let's do the integral. Let's do it up. It would be negative 1/3 x cubed plus 1/2 x squared plus 2x, and we would evaluate that from -1 to 2. And so I'd have negative 1/3, right? 2 cubed minus a -1 cubed plus 1/2, and that would be 2 squared minus a -1 squared plus 2 times 2 minus a -1. You'll notice my process is done this way, rather than taking the 2 through the whole thing and then the -1 through the whole thing, is because without the calculators, it kind of groups them together. So I have 8 minus a -1, which makes that 9. So I have -1/3 times 9. And then I have 1/2, that would be 4 minus 1, so that's times 3. And plus 2 times 3. And so I have 6. This would be -3 plus 6, right? Plus 3/2. And so I have 3 plus 3/2. Okay, so that gives me 9/2. And that would be my answer to that. Let's try some more. Find the area bounded by x squared and x plus 2. Well, here it is. To do this from without the graph, because having the graph is kind of nice. I was able to do that pretty easily. And doing something that you didn't even recognize, picking out that left hand and the right hand limit. But what you basically have to do first is find the points of intersection between the graphs. And so let's do that first. So that means I first have to say, okay, x squared equals x plus 2. Where does that happen? Where do these crisscross so that I can figure out between them, right? So it'd be x squared minus x minus 2. And so I'd have x minus 2 and x plus 1. So I easily see that it's positive 2 and negative 1. So what that tells me is when I'm doing this integral, it's going to be negative 1 to 2. Second step. Figure out which graph is on top. Which graph is on top. Now, your knowledge of graphs should help in this case. When we're talking about x squared, my hope is that you understand that that's a U shape and it dips down, right? And that x plus 2 probably cuts through that. And having that graph does help. But if you're not really good at those graphs, some knowledge of the functions helps because you could say, well, they're probably not going to run that line underneath and have it just open, right, where they don't cross. These graphs have to cross. And we know that they cross at negative 1 and 2. So it becomes a little bit more apparent once you find those points of intersection where they're going to hit. And so that tells me that x plus 2, or the line, must be the one on top. And just as I showed you in the previous question, you can group these two together. So in other words, this would be the integral of negative x squared plus x plus 2 dx, again from negative 1 to 2. Now that gives me a little bit of opportunity to do that, and I'm going to just take this time to move this down and do this question here. All right, so let's do that integral. To do the integral, Okay, here we go. So negative 1/3 x cubed plus 1/2 x squared plus 2x, evaluate from negative 1 to 2. And so I would have negative 1/3, 2 cubed, which is 8, minus a negative 1/3, so it becomes plus 1, plus 1/2, and we'd have 2 squared, or 4, minus 1, plus 2, times 2, minus a negative 1. And so 9 divided by 3, again, has negative 3 here. And we still have 6 here, and we still have 3 halves. You'll notice the answer to this is very similar to the last one because of where they're crossed and all that stuff. And the symmetry of parabolas, right? And so just to solve that out, we'd have, again, the 9 halves like we did before. Let's do this next one. Find the area bounded by x squared minus 4 and the x-axis. So there's a couple things, right? First thing we got to do is we got to figure out where they cross. And so where do they cross? But at negative 2 and 2. So I know, oh, sorry, I almost dropped my pen there. Negative 2 to 2. And which one is on top? Because that's the next piece. Which one is on top? Well, of course, the x-axis is. Well, how do I write that as an equation? 0, right? That's y equals 0. Minus this whole function. Very careful about your signs here because, again, you can cause some issues because you don't remember to distribute the whole negative sign through the whole thing. So I'd have negative 1/3 x cubed plus 4x evaluated from negative 2 to 2. And so I would have negative 1/3. I'd have 8 minus a negative 8. So that makes 8 plus 8. And then I'd have 4 and I'd have 2 minus a negative 2. So I have 16 here. And I have minus 16 thirds. So that would leave me with 32 thirds. And hopefully that's enough example for you that you can use those to understand what's going on when you're talking about the area between two curves.